All right, topic for today is vertex and x-intercept form for parabolas. The vertex is that middle point right there, and the x-intercepts are where the graph crosses the x-axis. A typical graph might look something like, oops, I gotta open this up. A typical graph might look something like this. This is vertex form. If you look at the graph, that middle point or vertex is right there where the x value is 3 and the y value is 5. That's also in the equation. If you plugged a 3 in for x, that would make the parentheses 0. And then adding 5 to that would give us a y value of 5. So y value is 5 at the vertex, x value is 3 at the vertex. A second type of parabola equation is something like this. This is called x-intercept form. Oops, turn the graph on. There it is. If you look at the graph, one x-intercept is at 2 and the other one is at 4. That is also in the equation. If you plugged a 4 in for x, that first set of parentheses would be 0. The second set of parentheses would be 4 minus 2 is 2, and if we multiply those together, we would get a 0 for the y value. Same sort of thing with the 4. If we plugged a 4 in for each of the x's, we would get a y value of 0, so the x-intercepts are at 2 and 4. Typical sorts of questions that you would get for this. This is in that vertex form, and also that little hat symbol there. Something like this just means squared. The vertex is at 1. Plugging a 1 in for x would make the parentheses 0. Square that, still 0, and then add 5 to get a y value of 5. To make a table for this, I would definitely want my vertex to be in the table, and then I'll pick a couple of points on either, a couple of x values on either side. If I plug a 2 in for x, this would say y equals 2 minus 1 squared plus 5. 2 minus 1 is 1, square it, it's still 1, plus 5, and I get 6. If I plugged a negative 1 in for x, I'd have negative 1 minus 1 squared plus 5, right? That minus is still there. Negative 1 minus 1 is negative 2 squared plus 5. A negative squared is going to be positive, so negative 2 squared is 4 plus 5 is 9, and this would be a 9 here. If I plugged a 0 in, 0 minus 1 is negative 1 squared, it's positive 1, add 5 and it's 6. Ooh, nice. I'm getting those matches on either side of the vertex, so I think I'm doing this right. And then if I plugged a 3 in for x, 3 minus 1 is 2, square that and you get 4, add 5, you get 9, and again, I'm getting those matches on either side of the vertex. For x-intercept form, the x-intercepts, if I plugged an 8 in for x, that would make the right side of the equation 0 or the y value 0. And if I plugged a 12 in for x, that would make the right side of the equation 0. So y would have to be 0, and there's my x-intercepts. To make a table for this, I would definitely want, it says vertex, I'll worry about that later. I definitely want to have the 8 in my table because that's such an easy number to plug in. And I'm just going to kind of go by ones here until I get to 12. I want 8 and I want 12 because those seem like they're important points. If I plug a 12 in for x, of course I would get a 0 for y, and then I'll just kind of follow my table. If I plug a 9 in, this would be, the y value would be 9 minus 8 times 9 minus 12, and the y value would be 1 times negative 3, negative 3. If I plug a 10 in for y, right, we're just going to replace a 10 with each of those x's. The y value would be 10 minus 8 times 10 minus 12, and that would be 2 times 10 minus 12 is negative 2. Oh, interesting. 2 and negative 2. So this would be negative 4 here when I multiply those two together. If you plug in an 11, I'll skip the details, you will get a negative 3, and we found our vertex. There it is, right in between the two x-intercepts. And there's our table. And that will do it for vertex and x-intercept form today.